Okay, so I'm going to do number 103 for you, but I was having a hard time visualizing it, so I actually had to draw a picture. So what I drew was, I have my 2 liters of oxygen gas collected over water. So that volume over the water is just going to be 2 liters. And the pressure that I know is actually coming from the water vapor and the oxygen gas itself. Okay, so then I take it away from this situation and I have a volume of 1.94 liters and a pressure of 785 millimeters mercury. So what I can already tell is that I took the oxygen gas, which was allowed to occupy 2 liters, and I put it in a space which allowed it to occupy only 1.94 liters. And that meant that its pressure had to go up slightly because it had more space here and now it has less space. So what I'm trying to find, that's how the water vapor and the oxygen can have the same pressure as the oxygen by itself. So what I'm trying to find is what is just the oxygen pressure, because I know its conditions here and I know its volume here. I can work backwards and find its oxygen pressure, and if I know that, then I have the total and the oxygen, and I can finally solve for just the water, which I know is going to be very, very small. So I'm going to use P2, V2, these 2's, are as equal to P1, V1. So I know 785 and I know 1.94 and I know 2 liters and X. And when I solve for X, I'm going to find that X is equal to 761. So I was right. Its pressure in the 2 liters is slightly less than its pressure in the 1.94 liters. So now if that's the pressure from the oxygen, then 785 equals 761 plus pressure H2O. And pressure H2O is going to equal 424, I think. Yep, 24 torr. Thanks.